statistical analysis test, linear regression. Here from our statistical analysis tool of Dataghurhi. What is linear regression? It is a statistical method used to examine the relationship between two numerical data. It determines whether one variable, which is the independent variable or predictor that can be used to predict another variable called the dependent variable or response. The goal is to know whether these two variables fit the best straight line known as the regression line. The data, I'll be using the data. Oh, I didn't open it. This is the data I'll use. The independent variable is the study hours, and the dependent variable is the exam score. The university wants to determine whether the students who study more hours generally achieve higher exam scores. Linear regression analyzes the relationship between these two and produces an equation that can predict a student's expected exam score based on the number of hours he or she studied. The research question is there a significant linear relationship between these two variables? Let's test it in the tool. Hypothesis statement. It can either follow two of these, either the slope, which is the gradient of a straight line, it can either be 0, that'll be the null hypothesis, that there's no linear relationship between the two variables, or it can follow this alternative hypothesis, where the gradient will not be 0. That will mean there is linear relationship between the variables. The significance level is kept as 0.05. Now the model summary. These are all the calculation results. The R squared is this proportion of variance explained by the model. The R squared means it is also called the coefficient of determination, measures how well the regression model explains the variation in the dependent variable. Here are other. Adjusted R square is similar to R square, but also considers the number of predictor variables in the model. It helps prevent overestimating model performance when additional predictors are included. F-statistic tests whether the regression model as a whole provides a better fit than a model with no predictor variables. The p-value is found as 1.0, but so it's greater than the significance level. Here is RMSE, root mean squared, average prediction error. It measures the average prediction error of the regression model, degrees of freedom, and this is the coefficient table. Coefficient, standard error, t-statistic, and p-value. And the decision of the results. It says that significant relationship found. Meaning the two variables is statistically significant. And here's the prediction equation. The 44.6095 is the intercept. It's the predicted exam score when the number of study hours is 0. 4.05 is the gradient, the slope value. And here are the visualizations of linear regression. First, this is the scatter plot. The scatter plot displays an individual observations along with a fitted regression line. The independent variable, dependent variable. Here's the interpretation of the plot. Slope, r squared, p-value. Residual plot. The residual plot displays the prediction errors called residuals for each observation. Residuals are found with observed score minus the predicted score. Here's the interpretation. Next is the QQ plot. The QQ plot is used to assess whether the residuals follow a normal distribution, which is one of the assumptions of linear regression. According here, the points follow the reference line closely, indicating the residuals are approximately normally distributed. Here's the expression, what it means. Next is the histogram of residuals. This one shows the distribution of the residuals in a histogram. According to here, the residuals are centered around 0 and form an approximately bell-shaped distribution. Here's the interpretation. Thank you.